This is about as simple an electric motor as a demonstration as you can do. It's basically a little coil of wire hooked up to the battery here and a magnet sitting there. And if I set it going, it'll happily run. There's a little bit of a trick to this experiment. It needs to be started off by hand and then it will run away quite happily. This is very simplistic, but it's a little bit of a cheat as well, because the coil cannot stay connected to this battery, because when it changes the field, when it rotates, the field will then be north-south facing the magnet and it would just stop. So to make it continually rotate, you have to switch the field off when the north-souths are facing. So to do that, what's actually done is that this is copper wire with an insulated lacquer on it. If you scrape the lacquer off one side but not the other side, it means it only makes contact one way, and that's when you have the poles facing each other, so they repel. And momentum will then carry it round in its off position until it lines again and gets another kick. So it's quite a clever little demonstration. This is a little bit more sophisticated, this motor. This one has the coil again, but this time there's a slipping connection here which will always maintain the current flow in the same direction because it connects as it rotates. And we have some fine wires here for slipping connections. So if we connect this motor up, we've also got our magnet here. Again, you can make this quite easily with some copper wire and just something to make the connections there. So this motor will turn quite happily with the connections slipping and always presenting the fields opposing the magnet, so it's constantly trying to run away. This is basically the construction of a large electric motor. So in a little demonstration we have basically this kind of thing set up, where we have a magnet with the north-south poles, and we have basically conventional current going around this coil here, but we have got connections that move. So the way that works is if the current is always in this position, so we're always going to get forces trying to escape from the magnet, but because we're on an axis, that effectively becomes a rotation. Again, I've got a little setup here with a magnet here, and instead of brushes, again, we've got some wires there for slipping connections. I have the rotor out of a small electric motor, which is able to move here, but the contacts can rub against the commutator. So if I connect 12 volts to this setup, you can see even with the very weak magnetic field, there's enough of force to run this motor, and you can see small sparks at the commutator. This is an actual motor out of a washing machine. I'm going to run it on 12 volts just now. So let's have a look at how this is constructed. So here we can see the main parts of the motor. This is the rotor, and like the other coil you could see earlier, there are quite a number of wound coils on this one, each one connected to this commutator. It doesn't use a magnet, it actually uses an electromagnet, so these are coils that produce the field winding, magnetic field. And if we look in here, these are carbon brushes which make contact with the commutator to pass the current to the windings that are in the rotor.